So we're going to be looking at some special cases for factoring. In this case, the first one we're looking at is what we call a perfect square trinomial. So the way you'll recognize it is because the first term will be a perfect square value and the last term will also be a perfect square value. And the middle term is going to be the square root of the first term times the square root of the second term, or sorry, the last term times 2. So we'll try it out. So we need to recognize that because this is of that form, the first value is a squared and the last value is b squared, just like this, a squared and b squared. But to find the factors, we need just a and just b. And the way we do that is by finding the square root of both of those values. So the square root of 36x squared is 6x. And the square root of 4 is 2. So a is 6x and b is 2. So because this is a perfect square trinomial and the middle value is positive, we can say that the factors are the a value plus the b value, all squared. And when I'm saying the plus or the positive 2 here, it's because that middle term is positive. If we wanted to verify that we're doing it right, I'll put it here, verify. We're going to take that 6x plus 2 and multiply it by 6x plus 2. And we'll get 6x times 6x, which is 36x squared. 6x times 2 is 12x. 6x times 2 is 12x. And 2 times 2 is 4, which we can combine 12x and 12x to get 24 x's in total. So we find out that yes, these are the factors because when we multiply them back out, we get the trinomial that we started with. So ignore my writing here. I did make a little mistake on this one. This is supposed to be a 72 in the middle here. So we should have minus 72x. So we're starting off the same way. We're looking at our first value and our last value that are both squares. And then I'm going to identify, even if it's reversed and even if my x squared value is at the end, I'm still going to name the first value a squared and the second value b squared, or the last value b squared, and identify a and b like we did in the last problem. So I'll take the square root of 16 and the square root of 81x squared. So a will be 4 and b will be 9x. And then just as a checking point, if I were to ever give you a problem that asked, is this a perfect square trinomial? You can always take the values you just solved for and make sure that if I multiply them by 2 times a times b, I'm going to get what is in the middle of this expression here. So I'll just show you that if I do 2 times a, which is 4, times 9x, which is b, I'm going to end up with 8 times 7, which is 72x. So that's good. We did end up with that 72x. And the reason we're getting positives here instead of the negative is just because when we took the square root, it was of positive values, but that's okay. So last but not least, I'm just going to show you the final factors. It's going to be a and b. But this time, since the middle term is negative, it's a subtraction between those two terms and all squared. So those are perfect square trinomials. And then the last one is difference of squares. So the way we'll recognize these are by looking at them and seeing a squared value, another squared value, and then a subtraction to represent the difference between the two of them. So we're going to always begin identifying a squared and b squared like we did before. And we're going to find a and b by again taking the square root of each, which will give me 3x and 7. And then in this case, what ends up happening, instead of plugging it into the form we had before, we're going to be plugging it into the following form. So we're going to put a in each of those and b in each of those, but the operations between them are going to be addition and subtraction. And the reason we do this was because if we decide to multiply this out to verify, we're going to end up with 3x times 3x, which is 9x squared, 3x times negative 7, which is negative 21x, then 7 times 3x is positive 21x, and 7 times negative 7 is negative 49. So looking at this, these two middle terms, I have a negative 21 and a positive 21. That's actually going to cancel each other out to end up with 0 x's. So we end up with 9x squared minus 49. So what ends up happening when we change this from a positive and a negative, it'll eliminate our middle two terms. And then last problem here. So we'll start off and look at it and say, well, 75 is not a squared number and 3 is not a squared number we recognize either. So just like we've been doing before, you always need to ask yourself, is there a greatest common factor that I can start with? And in this case, both are divisible by 3. So I'll pull out that 3 and be left with 25x squared minus y squared. And then 25x squared is a squared value and squared variable, and y squared is a squared variable. So we can now move on to using difference of squares to factor what is left in the brackets here. So we have a squared and b squared. So to find a and b, we need to find the square root of each. So we'll end up with 5x and y. So our final factors are going to be of the form, we'll have 5x in each of them as our a value, and we'll have y in each of them as our b value, and we add and subtract. But we need to remember we did factor out that 3 to start with, so that 3 is still part of the factored solution.